Hello everyone, this is Dr. Shachinandan Datta, and in this video lecture I'll talk about the ANCOVA. So in my previous lecture I have already talked about the theory of the ANCOVA, and this lecture mainly based on the practical or the exercise of the ANCOVA, and we do this exercise on our studio. So first we have to upload the data. I have already uploaded the data in the art studio, so let's check the data. So our data, it says that it has five different types of trees, type 1, type 2, type 3 and type 5, and it has age is in days of these five different trees, and with the circumference or the diameter of the tree. So it's an species of the tree is the orange. So we are taking data of five different trees and their age and then circumference. Then our idea is to check that whether is the circumference is basically it's directly depend on the age. If age is increasing, the circumference is increasing, and whether that along with the age, the tree type of the tree is impacting the circumference or not. So that type of the tree could be a cofactor or covariate here in this model. So first of all, we have uploaded the data. Now we have to attach the data. So attach the ANCOVA tree. Okay, so we have attached the data. Now we'll do the test. So I have talked about the theory. So ANCOVA is nothing but the combination of the regression and the ANOVA. So it's as basically a GLM or general linear model. So we'll run the linear model or the regression model, and then we'll after getting the result of the regression model, we'll do the ANOVA. I have talk about the theory of ANCOVA in previous lecture. So we'll do the test first. So we have to make the type of tree. Here the type of tree is basically a category variable. It is a category variable, and it's a factor variable also. So we have to make the tree as a factor. So tree is equal to as dot factor tree. So now tree is also a factor. Now we have to make the model. So first our first model is model 1 that tends to linear model of that circumference is depend upon the age. Okay, so that is the model 1. So we have to check the summary. So summary of model 1. So here we can get our result. So here you can check that yes, the circumference is directly proportional to the age, as here the R square is very good and it's a positive relationship. It's 0.83. So means if age they increase, the circumference is increasing, or diameter of the tree is increases. Okay, and it is a significant as the p-value is close to 0, it's almost 0. So and then we'll run the model 2. So our model 2 would be, so model 2, we are making this model 2 LM of circumference is depend upon the age and plus the tree or the category variable. Okay, so we'll check the summary of model 2. So here you can check, yes, the age is already, it's insignificant early variable. Significantly the circumference is dependent on age. And if we look at the type of tree, so type of tree as type tree 1, that is a control variable, so it's not coming here. So age 1 is the control variable, and tree 2, 3, 4, 5 will check that it's that type of tree along with the circumference is type 3 and 4 or 5. In this tree you can find a significantly it's depend the circumference on age. I mean, in this three different tree you can check the circumference is directly depend upon the age. Then we'll check our model 3. Model 3 is basically the interaction. So we'll check the interaction between the circumference, age, and it's an interaction between the age and tree. So predict the circumference. So circumference is depend upon the age and plus tree. And here we'll add the interaction between age and this is the interaction age and tree. Okay, so we'll check our summary of model 3. So here you can check that the interaction between age and tree, there is a significant interaction between age and tree. So but the tree 3 and 4 and 5 have a significant interaction between age and to predict the circumference, but in age or in tree 2 is not as significantly interact with age, that gives you the circumference. So means so if we look at our model, so here it's you can easily tell that yes, the type of tree is one of the covariate or cofactor for the predict the circumference, to predict the age in terms of circumference. But tree type 1 and 2, that one is basically control, we are taking as control, and that type 1 and 2 is not directly related to, means if age is increasing, the circumference is not increasing significantly. So if we look at so that is our linear model, or that is basically the regression is done. Then after that regression we have to do ANOVA test. So we'll do ANOVA of, so we'll do one by one. First ANOVA between model 1, so model 1 and model 2, sorry, model 2. So here between model 1 and model 2 you can check that in first model 1 is the circumference to age, and model 2 is circumference age and tree. So is yes, model 2 is significant, means the circumference is depend upon the age and tree, both type of age and tree. And now if we look at the ANOVA, we'll add the model 3. Then you can check yes, the interaction, that is the circumference age and tree, and age and tree, that interaction have also a significant. So model 3 is significant, so it gives you that yes, the type of the tree is also a cofactor, that along with the age, the type of tree is also a variable that impacting the circumference. Okay. Now if we look at draw some diagram or draw some map, so before that we have to install, or we have to upload this one package, that is LaTeX. So we will it's already installed in my system, so you have to install it. You install this package and then you load it in your system. So we have to load this Lati, and we'll plot some few plot. So first plot is, we'll check the XY plot. We'll check yes, we'll check the in 5 different tree. So tree 1, tree 2, tree 3, tree 4, and tree 5. So if your age is increasing, the circumference is increasing, and how your residual or the interceptor slope are fitted, and residuals are fitted to the your predicted. This is the predicted and these are the fitted. So but in case for plant 1 and plant 2, if the age is increasing and the circumference is not increasing that much significantly, but in case of plant 3, plant 4, and plant 5, you can see that its age is increasing, the circumference is increasing properly. So here the residuals is also good fitted for this plant. And if we check the other graph, the residual, then we'll see what are the how the residuals are look like for just 5 different plant. So it's model. Yes, so here you got the residual plot. So it's the fitted values and the residual value. So this is the fit and this is the residual value. In case of plant 3 and 4, 5, you can check the fitted values is not that much. There is a significant difference between the fit and the residual. Okay, but in case of plant 1 and 2, you can check that are not that much deviate from the fit to residual. Now if we look the one GG plot or GG scatter, for that we have to install the library GG plot. You can so make the GG plot, and you also have to install this package ggpur and library ggpur. Then you plot the GG scatter of our result. Then you can check. Yes, in check the how the in 3, 5 different tree, the age is increasing, the circumference how it varies, and in tree 1 and tree 2, that the fit and residuals are not that much deviated. But in case of plant 3, plant 4, and 5, you can check the how the area or the residuals is much more varies from your or data fit. So here from this ANCOVA analysis, you can tell yes, the tree type, or that's a category variable, it's a covariate. It gives you the circumference and the age. So basically a circumference is depend upon the age. Age is increasing, circumference is increasing, but along with the age, the type of tree is also a factor that gives the circumference. So but it's not all the type of the tree gives the same circumference, but along with age, type 3 or type 4 and type 5 plants give along with the age, it's also impacting the circumference. So that's all about the ANCOVA test, one-way ANCOVA, and we'll do the two-way ANCOVA in one next lecture. So thank you.